hammer, hand lens, field sacks. Now these are the things you should be collecting it from the departmental store. Okay, and typically they would take a deposit of about rupees 1,000. At least that's what they used to do. Now you don't have to pay rupees 1,000 now. I mean that was a deposit; you would be reimbursed back. Um, but on payment of that amount, on or keeping a deposit on of that one amount, the departmental store would lend you out this instrument: the clarinemeter compass, the geological hammer, hand lens, field sets, and so on. You should have, your geometry box, laptop, not for watching movies, but for doing things. Paper for working out things, full sleeve shirts and jeans. Now I know, like it's summer now already, and you don't even dream of wearing full sleeves. But the time when we go to field, typically it's in December, and it's a little chilly. Maybe not that cold, but it's a bit chilly. And definitely when you go out in the field, we work out in the forests, right? Forest and shrubs and places like that, where it's better to have a full sleeve so that you don't scratch yourself. Okay, and of course then medicines, regular medicines, money, mosquito repellent, and so on. So these are the things that you should be carrying. Now, just since this is kind of a virtual class and we're not getting to see you and you are barely getting to see us, make sure that you do ask us questions. Okay. In a regular time, we'll be interacting in a one-to-one basis, right? But now that it's not possible, at least feel free to ask us questions. Okay. Okay. Any question on this, guys? Any question? If you are not going to ask us
No,
questions,
sir.
we'll be asking questions. So better you know. No question. All right. Because interestingly enough, I have a multi-screen projection, so I can see your names too. So I'm going to ask your names. Call out your new names. Okay. All right. Hmm. I know there are 65 students. How come? Or no?
Uh,
There are 65 or
65 students.
55.
No.
How come 55
I
students?
mean, the number of registered student, you mean?
No, joined.
55.
Joined, I can see, yeah, 55, yeah, 56.
Is that
I mean,
correct?
including everyone, I think it is 56 altogether.
Okay, fine.
Mhm.
All right. Okay. So no question on that, right? So the next thing would be a kind of housekeeping thing. So I have just emailed you a link. Um, just give me 1 second. You'll see that I have just emailed you a link. Um, if you check your email, you'll see this. This is a Google Excel sheet, and when you reach out to that, you have gotten the permission for it, so you should be able to access it. When you do that, you would open up, and you see that it's called dashboard. So what this dashboard does is that it will list the material that we'll be covering in the class in terms of any reading material and so on. And if any, again, since it's a virtual thing and you are not able to go to the field yourself, we are going to give you like YouTube movies kind of thing, okay, so that you can watch out. So, for example, like today is the 25th of March, and we have class number 1, and you have the reading material like this. So you click it, you go to the folder, and you end up with this folder with material, and you see that there are few PDFs for it with reading material, some descriptions, this field trip instruction that I just showed you, along with a map. Okay, a map that we'll be talking about soon enough. Okay, so this is the reading material for today, and then you also have this watch link where you will have a video that you would be supposed to be watching as a homework. It's a fun homework in the next couple of days before the next class. Okay, so that would be kind of your assignment thing. Everybody okay with this? Any question? Right?
Yes, sir. Okay with it.
All right. So let's start it virtually. So what I will do is I'll show you the Google Earth. I'm sure like in today's time, all of you know what Google Earth is. And we'll be pretty much starting from Kharagpur. Okay. My internet is a bit slow, so it's possibly taking a bit. So that's where you are, right? The campus. Okay. And what we do is typically, I don't need to see an instruction. So those of you who are already in Kharagpur area, you know that we have one of the largest railway stations in the world. I think now it's third, but at one time it was the largest railway station in the world. So we were kind of proud of it. I mean, we're still proud, but earlier we were more proud. Anyway, so we catch up the Baleshwar local at 9:20 a.m. So we convene at the Kharagpur railway station, and from there we'll take a train to go to Baleshwar. Now, Baleshwar is a place which is kind of in here. So we take a train, which is about 2.5 hours, 9:20, and we'll reach Baleshwar, as you can see here, Balasore, as it says here. It's a near coastal town of Odisha, quite neat town actually, and we reach there about 12:30 in the afternoon. Get seated up in your rooms in the hotel, and you know reconvene back in the evening. So I'm kind of fast forwarding the whole process, and so like I said, so take down notes. These are important things that I just said. So you are in Kharagpur, and we came down to Balasore here. Okay, good. And this is our base station for the first few days of the fieldwork, which is in our case in this virtual world, which is like 2 days kind of thing. Okay, so we'll be staying in Balasore for a few days, and we'll be kind of taking cars from here to travel out in areas which are about 20 kilometers west of here to all these hill areas that you get to see here. Can you see the hills around? So these are the hills that we'll be going out to, and these are the things that we'll be talking about as a course of this fieldwork. Now, once we spend few days on Balasore and we cover the area, we'll be again taking cars, and from Balasore we'll be coming down to Chandipur, which is about 15 kilometers away. Okay, so we'll come down to the sea beach of Chandipur, and we'll spend the rest, 6-7 days out here, and we'll be kind of basically not taking cars anymore, and we'll be just walking around the beach and kind of learning things and so on. Now, what is the purpose of this whole fieldwork? The purpose of this whole fieldwork is to kind of get you attuned and kind of give you a first-hand experience on, of course, geology and what the processes that would take place and have taken place in the past, and things that you have learned in your textbooks or in your virtual class. How does that relate to the real world? Okay. Any questions so far? Any question? So again, this is, if I zoom out, so this is Kharagpur, and we're coming. Everybody can see this? Everybody can see this?
Yes, sir.
All right. I'll just take out the roads. Yeah. So we are at the eastern end of India, pretty much at the one of the eastern edges of India, I would say. And we start from Kharagpur, from the campus, take about 3 hours of train ride, and end up in Balasore in here. Okay. Now, what you are looking at is a sea beach of Chandipur. Now, Chandipur is also famous because, as some of you might be knowing, that this is one of the um, missile testing facilities of India. Okay, so this is where, in addition of Sriharikota in South India, this is one of the places that India tests its missiles. Okay, so it is a pretty kind of high security zone, high security area. So we have a lot of DRDO personnel and DRDO offices in and around. So definitely, you don't want to miss up. All right. Now, this crescent that you get to see, this is the crescent of Buribalam. So this is the Buribalam river here. Buribalam is a distributary of the Subarnarekha river, and it forms a very minute delta out here, a very small one. So in this area, the sea kind of encroaches, or what we call transgresses, within the land. Okay, so here you can see. So this is, if some of you would be knowing the geography of the place, this is Kharagpur. So Kolkata is just here. This is the Bhagirathi Hooghly River. So this is the Bhagirathi Hooghly River. This is Kolkata here, and this is the Sundarbans, the Ganga Delta. Okay, the Ganga River Delta. So that's Ganga, that's Brahmaputra, that's Meghna. If you can see my cursor, coming down as the largest, you know, river network in the world, and forming the largest delta system in the world, the Ganga, Brahmaputra, Meghna Delta. So we are just west of that. So these, blue things that you look at here, these are the sediments of the now forming delta of the Ganga, Brahmaputra, Meghna. Okay. So we are basically looking at the Bay of Bengal. Okay. We are looking at the Bay of Bengal, and this is the continental shelf. Continental shelf. Okay. There is a canyon here. There is an undersea canyon here. You can see that this canyon. This canyon is called the swatch of no ground. The swatch of no ground. Okay. So the sediments from the Ganga, Brahmaputra, Meghna kind of bypasses this continental shelf and comes down to the deep sea of the Bay of Bengal out here. So once we stand at the beach of Kharagpur, I'm sorry, not at the beach of Kharagpur, beach of Chandipur, what is the next landmass that you get to see here? Any idea? What is the next landmass from here and south from here? Any idea, guys? Dayanand? No, Deep, right? Deep? Any idea? Come on, you have to answer, right? This is all part of the grading. And this is a trivia question, right? I'm showing you something in the map, so it's not that difficult. Give it a shot. Deep? Rachi? Rachi?
Yes, sir.
Achha, Vidit. Okay, Vidit. So tell me what is the landmass, from down south of Kharagpur and Chandipur in here. You know this is India, right? That much you know. It's called, this landmass is called India, guys. Come on, at least say yes or no.
Yes, sir.
Okay, good. Thanks, Aruna. So could you tell me like what would be the landmass south of this? Just a wild idea, not required that you
Also,
know.
like south of Kharagpur, like near Chandipur.
Yeah. So Chandipur, this is Chandipur, right?
Yes,
This is
sir.
Chandipur. So if I go south of here, this is the Bay of Bengal, right?
Yes, sir.
And so we are moving out from the continental India. What is the next landmass that you get to see? Any idea?
Andaman and Nicobar.
Well, Andaman Nicobar is a little toward the east. You don't get to see anything. You end up, in Antarctica out here. There is no landmass So if you stand at the beach of Chandipur and you look at the sea, that sea literally continues to infinity. I mean, not infinity. I mean, it's kind of moves around and comes back to the Arctic Ocean here, but there is no landmass south of here. Isn't that incredible? So the sea that you would get to see from Chandipur would not have an end. It just moves on. See, it's out here in Antarctica that you will end up to. Isn't that cool? And we'll see, like, if we can take you, at least the beach one day for one day or so that you can experience this. Fine? Did you understand what I was just asking?
Yes.
Yes, sir.
Yes,
All
sir.
right.
Yes, sir.
Yeah. So that would help. Like that ESR thing would help, really help. Okay. So that's kind of giving you an orientation of where we are, right? And what we'll do next is talk about, the real philosophy of the things and where are we and what we're doing and so on. Okay. Now, my question would be kind of a little itchy in a sense that why do you decide to join geoscience or geology or geophysics per se? I know it's a itchy question, and I know it's kind of going back to you know um, something that you would not like to ask yourself. That maybe you aimed for something else and you didn't get it, and you ended up in geology. Isn't it? Isn't that correct? Right?
Yes, sir.
Be honest. Yeah. You know, you don't have to cry on it. 25 years back, that was the same story for me too, and I suppose Professor Basu also, and so was for Subroto and Prakriti and all of us. But you know, after 25 years or more than that, actually now, how many years? 94. Yeah, 28 years now for me, because I also had not 24. It's actually 30 years that I have been learning geology, because I had geology from my class 11. Okay, so I also wanted to do something else, get a different subject, and you know, somehow it didn't work out, just like you guys. And I decided to, okay, take up geology. Okay, why not? But then I liked it, and I liked it so much that I decided that I'll kind of pick up my career on it. And then I thought, well, I'll get a job on it. And then I thought, okay, this is cool. This is something I would like to do. And I stayed on, eventually deciding that maybe I should teach students like you, our next generation, or maybe next generation, who may also like geology or geoscience. Okay? So, no hard feeling. You have ended up here, try to learn it to the best. Okay? Now, believe me, and Shubhrata can possibly vouch for us, that this is one such subject that is kind of unique in its own sense. Now, there are so many subjects and so many possibilities. And I know, like, all of you, when you end up in your fourth year and eventually going to your fifth year, you would all have to go to the banks and the financial institutes and maybe computer agencies and so on, giving good bucks. All good. But if you want to pursue your dream, if you want to do something that you really love to do, work in the wild, pick up your life as an adventure, this is the subject you want to be. Because for us, you know, our profession is an adventure, believe us. And I'm not speaking I'm not just giving a false hope. Because we get to work in the forest, get to work in the mountains, get to work in the deep oceans and whatnot. Some of our colleagues go to Antarctica or the Arctic oceans to collect samples. Some of your seniors few days back, right, Shubhata? Didn't you? No, not you. David went. They just went to get filled, from the Sundarbans, the forest of the Sundarbans. Okay, so Prakriti did. Yeah, I now recall. Prakriti did. So it is one such subject where, if you love nature, If you want to be a part of it, this is where you want to be. All right. Now that brings in the question that what or why are we even going for the fieldwork? It's $1 million question because it's it's time, money, resource, and everything else, right? Why on earth should we pack up your bags and travel for 15, 20 days out of nowhere and just spend your time? But believe me, this is where you become a class. I know, like, again, for the pandemic, it has been a very different situation than what it used to be. And, I would doubt, like, if you even know all your classmates. But for, like, for even, having into this class, this is possibly the first time that you would be enjoying or you would like to be feel yourself as a part of the greater class, all the 50 students together. Okay, either geology or geophysics doesn't matter, you are one class. And I would ask Subroto to share a few moments with you, like, as we go through. So Subroto, think about it. Okay, be ready. So this is one such time that, yes, I know you hate it to begin with, and I know, like, all of the senior batches, like predecessors of yours, used to cards at the beginning when we used to have the intro class, and we used to tell them that we'll be going to the field so and so date and so on. They would cards with all the bad words that you know. But then after coming back, let's hear from Subroto. After 10 years back, after 10 years, what he has to say on that. So Subroto was one of our first students to go in the field with us to the same place that we are taking you virtually. Subroto, would you like to share a couple of words?
So, actually, geology is some subject is one of those subjects which can't be understood. Which we cannot understand in a classroom. It's it's the actual classroom is the field where you get to see the actual manifestation of what you are studying. Without seeing that, you won't be able to understand anything. So the backbone of geology is fieldwork. So you need to go there, and once you start seeing the talks and maybe the terminologies that you must have read by now, you will see in actual sense what does that mean. And plus, uh, the batch that you are seeing in the virtual meetings, the the, uh, the enjoyment that be you will basically enjoy the get-togetherness, as well as in a fun way you will be learning geology. So it's one of the memorable moments. And yeah. uh,
So Subroto, since you've been a student to this course 10 years back, how do you rate it? After so many years and being in the industry and coming back and so on, how do you rate it?
it's one of the at least for the second year batch, it's one of the important part of the coursework, the complete course, because without going to the field work in second year, uh, anything that they must have read in the class won't make
Mhm.
much sense in the
True.
field. In actual sense, when they will see, they read the dip and strike, they'll see what does that mean in actual sense. That's
Yeah.
a very important thing.
And just, not on a not academic part, was this also fun for you guys?
Yeah, yeah, sure.
This is where the class kind of
The
became a
bond,
class,
yeah,
right?
yeah, yeah. The bonding between the class actually starts from that field work.
Well, unfortunately, we cannot offer you an offline experience as of now. But as I said, like, we'll be watching and we'll see, like, how if we can make it up. All right. So the question that Shubhrata raised is quite important. That you would not know what the subject is unless you go to the field, because there is no laboratory, no virtual platform that you can avail to that would really be able to give you the experience, the simulation, the feeling that you would enjoy when you go out in the field. Okay, there is no way we can proxy that. We'll try to do as best as we can, but again, we possibly would not be even able to do 20% justice to what we would typically do. But anyway, life goes on, and we have to do what we need to do. So the question that I would like to start with, and okay, so first of all, like why did we select this place? Like where we go for the field? Well, there is a couple of reasons. Number one, it's easily accessible, so it's a day trip kind of thing. So it just takes 3 hours to end up in Balasore from Kharagpur, and it's a pretty non-invasive train journey, so it's good. And once we reach there, we have a kind of um, kind of mm, let's see, um, uh, like a staying place where all of we kind of stay together. You and I and Professor Basu and Shubhoto and Prokiti all stay together in a hotel, which is just across the Balasore station. And in the evening, uh, so after you reach, you take rest for 5-6 hours, and in the evening, we'll have this um, meeting, okay, on the courtyard below the banyan tree. And what we're gonna talk today in the next few minutes would be kind of an extempore of that discussion. So, okay, so we are in the evening now, and we are going to start a bit of a discussion on what we are or where we are and what we plan to do. Now, I told you that there are specific reasons that we decided to come to this place and start looking at things. The reason being that this place, Balasore, and its surrounding is a part of the Earth, the planet, where the planet, the you know the part of the planet is actually regarded as one of the oldest part of this planet. Okay, so Balasore and its surrounding lie on a part of the crust of the planet, which is again regarded as one of the oldest in the world. What do we mean by that? Well, and so you guys already have the course on the intro course on geoscience, right? All of you. Could you tell us like what exactly happened when the Earth was formed, guys? Can anybody tell me? Sahil? Just whatever you can recall. No big deal. Whatever you can recall. When was the Earth formed? Give and take.
So 4.5 billion years ago.
Very good. 4.5 billion years. And how is it? What are the hypotheses that how was it formed?
Hydrogen helium reactions.
Okay. What happened?
Those fusions just took place, and then certain kind of many of the cycles happened after that, and thus we just get our Earth.
Okay. So is it that the hydrogen helium kind of collided with each other and we are here? Is that so?
It's happening
right?
with time, I think.
Yes, it's happening with time. So could you go back a little bit and tell? Yes, hydrogen helium is all fine and it's still happening. So what are the hypotheses? Like what happened?
So that several chunks of like molten mass broke apart from the sun, and like then they settled into their orbits, and like it slowly solidified.
So as per the popular hypothesis, there was this gaseous nebula which kind of condensed to form the sun, right? And the sun, which is still a kind of like a ball of fire and a ball of burning gases, it kind of broke away parts of it And as you said, like it kind of settled, pieces of it settled, moving around the sun and became the planets. Is it correct?
Yes, sir.
Okay, good. How many planets that do we know of?
Sir, in the present solar system, like
Yeah.
8 planets.
Okay. What are those? What are those?
Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune.
Okay, and arguably Pluto, right?
8 major planets.
Yeah.
Others are
Well, Pluto is arguably regarded as a planet, but there are some reservations on that. Okay, 8 or 9 planets. Fine. So these 8 or 9 planets would kind of break out from the sun and kind of start moving at hot ball of gases, right? And then it started to cool down. At least for Earth, it cooled down, and eventually, after 4.5 billion years, it became the planet that you and I are living on. The planet with all the trees, all the birds, all the beautiful sky, the towns, the people, and of course the campus, right? But this 4.5 billion years have kind of moved in between from the day that it started and day where we are today. And definitely, as you can imagine, that it was not a very linear process, or just this happened after that and so on. So what would have been the first things that happened as Earth got separated from the sun as a ball of gas? What happened?
Can you repeat?
So as I was telling you, and as you guys said, that the ball of gas um, separated out from the sun to become Earth, right? The planet Earth, as we know today. And this ball of gas is now moving as a third planet in the orbit. Tell me, like, what happened? What are the next logical things that would have happened?
So that the denser part of the melt was concentrated towards the center of the body and the crust solidified over time.
Very good. So basically, this ball of gas, the hot ball of gas, started condensing, isn't it? It started condensing so that the gas now slowly became liquid, some of it, okay, and some started kind of solidifying, what you call crystallization, and the denser part of it, which is mostly made of iron and magnesium, they started to sink in, right, and go toward the center of the planet, forming what do you call it, guys? What do you call it?
Core.
This heavy thing, yeah, the core, yeah, the core settled in the center of the Earth, and then you have over the core and up to the top of the Earth. What are the layers that we know of after the core or above the core rather?
Crust and mantle.
Okay, it's mostly the mantle and a very thin crust. So you might think the crust. Have you ever seen boiling milk? Have you ever seen that? Yes.
Yes.
Okay. So when the milk boils and then you let it cool, what happens?
A
There's
thin layer forms, sir.
Sorry, second. There is a layer of
A thin layer of, I don't know, fat forms
yeah,
above.
cream, right? A layer of cream kind
Yes.
of starts developing, right? So you might imagine that this is pretty much exactly what might have happened in the early Earth. So the mantle, which actually forms the most volume of the planet, the inside of the planet, is still kind of like a molten thing like the milk. And there are heating processes that are going on. they're still kind of boiling, and that boiling phenomena would eventually, like the uppermost part of it, which is in contact with the outer atmosphere or outer space, would now start cooling down and started to form like a crust, just like the milk, the layer of cream that we talked about. So you can imagine that the crust that we're living in, which is at most 70 kilometer thick, at most, and we are talking about the mantle, which is few thousands kilometer thick, and the crust in most places is about 10 to 15 kilometers thick. Okay, it's only in very exceptional area that it is 70 kilometers. Most places it's about 20-30 kilometers. Some places it's even not even a kilometer. Okay, so it's a very thin thing. It kind of stays on this molten magma, sorry, the molten mantle, and kind of floats on it. Okay, so most of the planet is literally the mantle. If you take out the core, it's mostly the mantle. Now, if you think about this early planet, as the Earth started cooling down from this hot, ball of gas or ball of molten material, the first crust started forming not everywhere, not as all the continents that we get to look at. It started forming only in very specific places, just like kind of like a seed of a plant, you might think. And it started forming uh, only in very few places, as I said. One of them was in India. One of them was in the Canadian Cretons. One of them in South Africa. One of them in Australia. One in Antarctica. So there are only these small seeds of crust that started forming, what you call the continental crust. Okay, and these are what we know about at the most ancient part of the planet. Okay, the most ancient part of this planet. It is estimated that it is about, uh, let's see, so the Earth formed about 4.5 billion years, right? So the oldest parts of the planet that we know of are about 3.8 to 3.7 billion years. So almost give and take 1 billion year, nothing happened. Okay, give and take. So for 1 billion year, the Earth was still kind of a boiling thing. 1 billion year, and then after a billion year, kind of like a billion year, there are small chunks of solid crust started forming, pretty much like the cream of the milk that we talked about. And there are, as I said, very few places on this planet where those those continental crust started forming and are still preserved. Okay, the age of those rocks are give and take 3.6 billion years. Okay, 3.6 billion years from today. When we are looking at the history of the planet, those are the most ancient things that we can look through. Okay, this is the most ancient part of anything that happened on Earth that is still visible. And Balasore, the place that we go for field, is one such place. Okay, not necessarily in Balasore, but in and around Balasore. So these part that we're going to, this area that we're going to, is called is regarded as one of the most ancient part of this planet. It's called the Shingbhum Craton. Craton is an ancient part of the planet, which formed in those days like 3.5, 3.6 billion years back, and then things happened on it for few millions to billions of years, and then it kind of remained silent for the last many million years. Okay, that's called a craton, where nothing happens nowadays. So this place that we are going to is the Shingbhum Craton, which is on the easternmost edge of India, the continental India that we know. And if you look at the map, again, it kind of lies, so this area here, if you can see the cursor, this area here is the Shingbum crater. This is South Bihar, North Orissa. Okay, the Shingbum crater. India has 4 cratonic provinces, so 4 parts of the country where you find these very ancient rocks. One is Shingbum, one is Dharwar, 4 or 3, 3 I suppose. So one is Shingbum, one is Dharwar, and one is the Rajasthan Delhi belt. Okay, so these 3, parts of India did actually form around 3 billion years, give and take 3 billion years back. So these are some of the most ancient part of the planet, and we are just fortunate to have our first fieldwork on this site. So we end up in Balasore, which is on in the easternmost edge of this Shingbum crater. Easternmost edge, because as I said, I'm sorry, I kind of showed you wrong. It is not this area, but this whole area. This whole area is the Shingbum crater. Okay, so we are literally on the easternmost edge here somewhere. Here, it's the easternmost edge of the Shingbum crater, beyond which you don't have these ancient rocks anymore, and you have the sediments kind of filling up on the rocks. So the rocks may still be kind of existing down below, but not exposed, not on the surface. And there are sediments from here onwards, so no exposed rocks, and you have the sediments up to the bank of the sea, up to the beaches of the sea. So these are the last visible rock masses on the Indian continent at the eastern edge. Okay. So the purpose of this fieldwork that we are going through is unlike any other subjects that we would be ever going to get our hands on anything, any other subject. This is one such subject that we like to travel to the time. We are literally on a time machine, on a virtual time machine, and we play with the time. So in all other subjects, you have X, Y, and Z, right? The 3 dimensions. However, in geoscience, we also have the 4th dimension, the time, and we play with the time. So what we're going to do in the next few hours, like today and the next week and so on, we would be literally kind of traveling through time, back and forth, and trying to understand what has happened in the past and what is happening at present. How? Well, as I said, that from Kharagpur, which to my understanding was kind of last sedimentation happened during when the dinosaurs were still walking on the planet. Okay, dinosaurs, literally. So that's when the last sediments, the campus, the sediments that you get to watch on the campus, possibly they got deposited around the time when the dinosaurs were still around. Believe me or not. Could you even sense the kind of the pristineness that we are handling with? So the same sediments that you walk on the campus and you get to touch it and you can see the tree grows, those sediments and rocks down below, they were deposited when the dinosaurs were still on this planet. Any question? Any question? Guys?
No, sir.
All right. So from there, we take the train and we end up in Balasore. As I said, it's the easternmost edge of the Shingbum crater. And this Shingbum crater, as I said, it's one of the oldest part of the planet, believed to be somewhere around about 3.6 billion years old. Okay.
Yeah, Vijay, just sorry for the interruption. Yeah, you can you can show them the map also. I mean, we have that.
Yeah, I'm going to do that. So maybe we'll take a 5 minutes break, and then we'll come back to that. Okay.
Okay. That's fine.
So the easternmost edge of the Shingbum crater, which is again the oldest part of the planet. So we'll go back in time, and then From Balasore, as I said, we travel to Chandipur. Chandipur is one such place where you get to see many of these things that happened in the ancient times, in the very ancient times, to be happening today. You get to see how the rocks are getting formed. This is the same process, physics wise or chemistry wise, the same process that might have happened back then, back in the past, and the rocks got formed. So, through the through the scope of this fieldwork, we'll try to move you through this time, go back to this 3.6 billion years, and come back to the present to show you how the Earth is forming. All right, good guys.
Yes, sir.
All right. So since it's about an hour, why don't you take a 5 minutes break and then we'll reconvene. But make sure to be back on 5 minutes. All right.
So we start again at 7:12,
Yeah.
7:15.
Yeah.
Yeah.
7:15. Yeah. 7:15. No, phone করছি তোমার
Oh, okay. Mhm.
Am I audible? Am I audible, students?
Yes. Yes.
Okay. Yeah, I was not able to unmute myself. Okay. So, like I was telling you before the break, that we are looking at this easternmost edge of India, and we are looking not only at the landmass but also the history of the Earth's evolution. And what we're looking at is one of the most ancient part of the planet out here, and also some of the things that are happening as the most youngest, if I may say, the youngest rocks, or even the rocks which have not been even formed yet, which are forming in these blue things that you get to see here. So in the next few hours, as I said, like we'll be talking about that road that travel through time. Now in geology, you have learned that there is some subject called stratigraphy. Have you heard about that term? Have you heard that term, stratigraphy? Guys? Guys?
Students, have you learned stratigraphy yet? I mean, have you been taught the subject stratigraphy by any of the teachers? I think the geology students must have come across this subject, isn't it? Anyone from geology?
Geology is not having the stratigraphy this semester.
It
This
is.
semester, and you had one introductory course, right? Introduction to Earth Sciences and all.
Yes, we have.
So there also you came across this terminology, right? This stratigraphy, this particular thing. Nikhil,
No, sir, not that much deep. Some basic stuff.
not that much.
Some basics
Okay,
are there.
what
No?
about
Yeah. The history of Earth.
and what about the geophysics students?
So we have it this semester. So we have done the basics of stratigraphy.
Basics, right? Okay. So
So,
some
so you
idea
know,
you have,
yeah,
right? Yeah.
you know, like what the planet is and how the Earth is forming and so on, right? Don't you, guys? You know that part, right?
So can you repeat your question?
Yeah. The question is that you know the basics, the very basics of the rocks, like how the rocks are laid down and so on, don't you?
Yes, sir.
Okay. So I'm showing you kind of a table. You can see in the screen. You see that in stratigraphy, or which is called the history of the Earth. That's what the subject means. The history of Earth. So I'm showing you the history of this Shingbum crater, Shingbum province that I'm talking about. Okay, the Shingbum province, like what I mentioned just a few minutes back, and I'm going to talk about very briefly the history of it and what are the things that you may expect to see here. Now, as by the rules of how this history is written, so we think like the oldest of the rocks would be lying at the base, and then it would be the second old, the third old, kind of stacked over it, right? Like strata or beds. So you can think of let's see, like a mattress. So you put the oldest mattress on the floor, and then you put another mattress on the top of it, which is second old. Then another mattress on top of it, so third old, and the youngest of the mattress would be lying just above, okay, on the top. So the youngest of the rocks would be lying on the top. So in this series that we're looking at, you have the oldest of the rocks down below. You can see my cursor. Can you see my cursor, guys? Can you see my cursor?
Yes, sir.
Yeah. So, like I told you, the oldest record of rocks that we ever have in this world are 3.8 billion years. 3.8 billion years. So 3,800 million years. You can imagine. Okay, like when I was a student, I had a story that if you assume that the age of this planet is like one whole year, like the 365 days, and the 12 months they're in. So in this 365 days or 12 months year, till the end of November 30th, there was no life form. Okay, so if 1st January is when Earth started forming from the sun, so till November 30th, you didn't have any life form happening on this planet. And it was only the 1st of December that life started on this planet. So for the rest of the 11 months, the Earth was kind of barren, and at least what we get to know, okay, somewhat, the Earth was barren, and it was just the history of the rocks. And if you think about, the let's see, the dinosaurs, possibly kind of showed up only on the 25th of December. Okay, of course, it's a relative scale, right? So the dinosaurs possibly just showed up on the 25th of December and kind of died on the 28th of December, if you may say. So where are we, human? I mean, we think like we are the ruler of this planet, right? We literally got into this planet, at 11:50 p.m. Okay, 11:50 p.m. to the new year, 10 minutes to the new year. That's as new as we are. Okay, if we take 1 year as the age of the Earth, we are here just for 10 minutes, before the new year starts. So, in all a sense, we human are nothing compared to what the planet has been, or the planet has gone through. Okay, so we have to keep that perspective, okay, and that kind of gives us a good way to think about the time scale, like what are the amount of time, the volume of history that we are working with. So all the things that we fight through, and the ancient civilizations, the medieval era, the Renaissance, the French Revolution, the modern World War I, World War II, and maybe the World War III that has started. These are all in seconds in the arts history. Okay, so we are literally less than minuscule in a whole stretch of time. Now, so if I have to, and all these times from the 1st of January and through on, I told you that for the first 1 billion year, there is no record. There is no record actually, because whatever rock that might have formed, it's all gone. The oldest that we can get is possibly from the 1st of April. Okay, after a billion year, assuming the Earth is about 3.8, sorry, about 4.5 to 4.8 billion years. So let's assume that the first example of rocks that we get to see on this planet appears on the 1st of April. So in this series that we're looking at the base, you have something called OMG. Now, OMG is not the OMG that you know of. It's not the oh my god. Okay? It's called the older metamorphic groups. These are rocks, the very early rocks that are ever found on this planet, which obviously they were igneous rock to begin with. Igneous rocks, that's the mother of all rocks. And these rocks then went through what we call metamorphism, and then it kind of metamorphism is a process by which a rock would change its minerals and its form, its texture, and so on. And the older metamorphic groups that we find in the Shimun province that are still available in some of the portions of the Shimun province. One of them we think is very close to where we do the fieldwork. So as I said, there are very limited places on the planet that where we find this. These groups of rocks are known to be of 3,800 years old. 3,800 years old. Okay. So these oh my god rocks or older metamorphic group rocks, these are 3.8 billion years or 3,800 million years old. And these are rocks we we doubt that we have seen one of them, but again, neither Professor Basu nor I am what you call a petrologist, so we are not very sure that that is the kind of rock. But we know that within the area, like within about 25-30 kilometers of where we did the fieldwork or do the fieldwork, there are some remnants of these rocks. And then there are also what we call the OMTG, older metamorphic tonalite gneisses, that you get to see here as biotite tonalite gneiss. These are a little younger rocks, 3,200 years old. Okay, so these are the most ancient rocks that you find on this planet and are present in our study area. Now, as I said, that we are not very sure that we get to see this, but we believe that they may be present around. What we get to see here, we don't get to see this RNO group of rocks. We don't, because they do not exist at our site, but they exist a little southward. These are the rocks, this RNO group of the rocks are the rocks which would host all the iron ores that we know of. The iron ores in this country, all those Tata mines, all those big iron mines like Bailadila, Noamundi, Jadugora, all those mines hosting the iron ores, which is kind of, the buildings you make, the cars you make, whatever infrastructure that goes on in this country are based on the iron, right? The iron pipes, the stainless steel, they come from these rocks, the iron ore group. But unfortunately, we don't get to see them in our study site. I mean, in the Balasore area. What we get to see is the next group of rocks called the Shingbum granite. Shingbum granite is one of the largest granite body, again one of the largest in the world, and the Shingbum granite is one of the most extensive one, like it's few hundred square kilometer around. Most of the rocks that we get to see in the Balasore area are the Shingbum granite. Okay. Any question? Any question, guys? Any question? So these list that I'm showing you, which is in page number, is the third page of the 5 pages that I've shared of Ravindra Kumar. That's the PDF name, Ravindra Kumar to print. So of the 5, if you come to the page number 3, and you should find it in your dashboard link that I just shared with you, you would see that this list is given, and this is a succession of rocks that ideally you should find in any one place in a Shingbum craton. But in nature, you never find all of them in the same place. So what we have to do, we have to, kind of, it's like forensics, right? I mean, so you have to see evidences and you kind of build that up as a table of time or events. So the Shingbum granite is the most prominent rock type that you would get to see in your study area. And then you see that there are different names, right? A lot of names. We don't get to see most of these in our study area. And the next rocks that we get to see are these granophyres, the Arkashani granophyre. Okay. These granophyres, again, something that Professor Basu would show you pictures of. This is one of the last rocks that we'll get to see in the field. Okay. And these granites are about 2 billion years old. So from the Shingbum granite to the Mohivan granites or the Arkashani granophyres, it's about 1 billion years. You can imagine 1 billion years. And then we would definitely see some dolerites, newer dolerites. Okay, these are the next type of rocks that we get to see. Have you guys seen dolerite? Guys? Have you guys ever seen dolerite?
Physically, we don't have seen any of the rocks.
Well, how about if I tell you that you are lying? No, I'm just kidding. Of course, you don't know that it's a lie, but you are lying. Okay, Nikhil? Where are you from, Nikhil?
I'm from Patna.
You are from Patna. All right. Let's see. You are in Kharagpur campus.
No, I'm in my home right now.
Your hometown. Where in Patna? I travel Patna all the time. Where in Patna?
In old Patna, Patna city.
Patna city. Okay. So you are in your home.
Yes.
Okay. When you step out of your home, what do you get to see?
Streets, roads,
Very good. Roads and streets, right? That's the most obvious thing. What are the colors of those roads and streets?
grayish or
Grayish,
blackish,
blackish or grayish. Fine, fair enough. What are those roads made of?
cement.
Cements. Come on.
Oh,
Don't tell me cements. Bolo? Bolo, bolo. Give it a shot. An open question to anyone. What are these roads made of?
Asphalt.
Asphalt. Okay, very good. Now, asphalt is the kind of the binder, right? But what are the main material that the roads are made of? Haven't you seen the piles of stones that are laid around and which kind of
yes,
mix with
yes,
the
yes,
asphalt to make the roads? Haven't you seen
yes,
that?
yes,
What are those stones? Have you ever thought about?
yes. The name I'm not knowing right now.
Those are
That's
dolerites. So at least in Eastern India, the greyish rock that you get to see, they are the dolerites. And many a times, at least in Patna and Kolkata and Kharagpur, when you look when you look at the rocks and you see these gray to black color rocks that have been mixed with asphalt to make the roads, they are essentially the dolerites that are coming from this area, this Balasore and surrounding area. So these roads and streets that are you are walking through, they are literally made of these rocks, which are about 2 billion years old. Are you able now getting a sense to the antiquity? So obviously you never, again, when I said you are lying, it was not in a real sense. You didn't know about this. So these roads and streets that you get to see in most parts of Eastern India are actually from these dolerites coming from this area. And these dolerites are made of are coming from this Shinbum province about 2 billion years old. Okay, guys, did you follow that?
yes.
So, so in our study area, this is what we call a legend of the maps. So we see that you get to see. I don't know. Are you able to see it? Yeah. So these are the rocks that you get to see. So these are the OMG or OMTG, older metamorphic tonalitic gneisses. It's called TG here. Okay, and these are Shinbum granite. Shinbum granite. That's the main rock unit that you will get to see. And then you will have something called the granophyres. Again, Professor Basu would explain you that. The laterites that you will get to see. Again, the granophyres are about 2200 million years. And eventually, you get to see the dikes. Let's see where the dikes are. Do you see the dikes here? Sorry, these are the alpha basics. No, not this one. Here supposed to be NB. Oh, up there. So in the Chandipur beach, we'll be looking at these: the sand, silt, clay, BF, unsorted. Okay, the present day deposits. Okay, so you see, like this scale from the base, it's about 3,800 million years, and it is coming to day zero up here. Okay, and let's see here, ND, neodolerites. This is 2 billion years. Okay, the ND 2 billion years. Fine. Again, I know like none of this kind of is registering in your mind, and I would be in the same place if you were also telling me this. So let's look at what we call a map. So this is what we call a map, a geologic map. It's not a geographic map that you are used to. So if I go back to the Google Earth image again, so in this area, so what we're looking at is the surface, right? So if I take out all the vegetation cover, all the soil cover and everything, we end up with this. Okay. And the same river delta that we are talking about here, just for reference, is here. That's the Buribalam. Okay. So see that most of this area is yellow. Yellow is the newer sediments, sediments which are less than 10,000 years old, and possibly these greenish yellow sediments are, almost day zero, like they are forming now. And then we have this red area up in the northwest. So we are living in the Balasore town, which is here. Let me zoom in. So we are living in the Balasore town here, and we take the car to go through this red road and take a right turn to come to the town of Nilagiri. This is our location number 1. So could you just mark in your notebook location number 1? So this is our location number 1. Now Professor Basu would show you the photographs and things like that. What are the rocks that we get here? These are the red rocks that you get to see. That's this red with white cross are the Shingunganite, and these red ones, pure red ones with 8G, is the Hornblende. Don't worry about what they are. In general, they are granites. Okay, granites. Granites are one of the primary rocks that you'll be taught and you'll be able get to see. And within these granites, you would see this green color linear stuff. If I zoom in, do you see like this green thing? These green colored things? Do you see that?
Yes.
So yeah, so we look at these green things. These are what we call the newer dolerite dikes. These are about 1 billion year younger than this red thing. Okay, so these dikes, these rocks were formed 1 billion years after the red rocks were formed. So we come to the town of Nilagiri, we get down from the car, and we take what you call, like a path, like a village path, and we walk up. We walk through, initially the village, the village houses and so on, and eventually we target to come to this hill, 545, that you get to see. Do you see the name 545?
Yes.
Yes, sir.
So this is our location number 1. We are climbing up the hill, and we are kind of somewhere, at a mid height, and we stand at a place where all of us can spread around. And now Professor Basu starts giving you the lecture. Professor Basu.
Okay, thank you, Abhijit. You just unshare it, yeah, so that I can start sharing.
Yeah.
Okay, so let me see. Yeah, share. Okay, is this visible?
Yes, sir.
Okay, so before I start showing these pictures, just I hope that you can get an idea what Professor Mukherjee was trying to get at. So that is the idea of time, essentially, right? So in this location where we do this field work with these second year students, essentially preserves the entire time. I mean, from time 0 to the from the beginning of the earth to time 0, almost the entire time is preserved. and manifestation is in terms of different lithologies and different natural materials that already have been talked about. So you should get that sense what Professor Mukherjee was trying to convey. Okay, so the first place where we take the students to is Nilagiri Hills. Already Professor Mukherjee has shown the the geological map and where Nilagiri was written, if you remember, and that is within the Singhung granite. Singhung granite means which is actually 2.9 billion years old. I mean, it is more than that actually. Okay, so I mean, and which is dominantly present surrounding Balasore. Okay, so that is the most abundant rock type, okay, or lithology that you get to see. Now, let me show you this hill. Okay, this is the Nilagiri hill actually. There is the first spot where we go. Unfortunately, I do not have a picture while climbing up the hill. It is when the field work is done and we are coming back, and you can see some of the faces of the students. They are quite exhausted. Okay, so the thing is,
sorry, ma'am, I can
yeah.
see you here and follow me here.
so the thing is, actually we take this kind of trail marks, okay, and we reach to this place, okay, in a higher altitude, and then we show different things that we observed over there. Okay, so this is the hill. Actually we went up to this hill and now we are coming back. Anyway, I'll show you some other pictures also when we are at a certain height. Okay, so this is not the highest spot, I would say, but already we have climbed up to a certain level. Okay, it is already a higher place than the previous one, and these are the rocks that we are observing now, actually part of this Singhung granite. Okay, what Professor Mukherjee just has said. Okay, so this is actually Singhung granite. Now, one thing, yeah, this is, you can see that the students are all around at an altitude, and they are observing different things. They are measuring, or they are taking some data with the help of clinometer and other devices that we have, or other tools that we have. So now the thing is, one thing is very striking. If you just think of in this way, this granite that that granite is a plutonic rock, right? So this granite actually essentially forms subsurface at a great depth. Actually, it forms. Okay, how come that these granites are making this much high hill? Okay, so that is isn't it surprising? The rock that is formed at a great depth is forming high hills here. And not only here, we can get to see granitic hills in different places. Okay, any idea how do we see this granite at this level? Because they are formed, they are plutonic rocks, so they are formed at a great depth, and the pluton actually cools down slowly, and therefore when you look at a granitic rock, you will be observing the minerals are visible, right? So it is actually granite shows phenolitic texture, right? Equigranular phenolitic texture granite normally shows. So here also of course you do. It is from far. The picture is taken from far, and if we take picture which is very close to the rock surface, and if it is a broken part, then we will be able to see individual mineral grains also. Okay, so therefore in the item list, Professor Mukherjee was saying, so these are the important items that we normally carry. Why it is important? You see, in that list, if you look at, you will see items like a geological hammer, okay, a lens, okay, a hand lens is there, if you just look at that list again, you will find that hand lengths. So what are they for? The geological hammer is to break the rock to see a fresh surface. Why? I mean, why do I say fresh surface? Because this, this surface, if I, let's say, if you are able to see the cursor, these of course all are single granite only. Okay, but these surfaces, shows these surfaces shows weathering effect. Okay, they're very dull, and they actually do not resemble to the granitic texture that you see in hand specimen in the laboratory. Okay, why? Because you are not observing the fresh surface. Okay, the surface you are observing, that is a withered surface. So what we do, essentially, we take out our hammers and we hit these rocks to break a piece. And when you break the piece inside, and if we look at the inner portion of that broken part, then we observe the fresh minerals. If something is very, very small, if it is very fine, normally in case of granitic rock, they are phenolitic texture. I mean, you see phenolitic texture. That means it is visible by naked eye. Okay, all the minerals are also visible by naked eye. But if let's say some minerals are very small, or if you look at a volcanic rock, okay, so the grain sizes would be very, very small, right? So the hand lens would be useful to take a look at the individual mineral grains when the mineral grains are very, very small. For granite, it is not so. Most of the minerals are well visible. Okay, so it shows equigranular phenolitic texture, and it is pinkish in color. As you can see, it is a typical granitic rock. And when you look at this particular hill, you see, just a minute, I didn't want to show this picture. This is the lunch time actually. Okay, so we were doing the field in this area, and at around 1:30 or 2 o'clock, we just sit on the rocks there itself, and some student is offering us these biscuits or some snacks. So that is our lunch. In the field, you do not expect your lunch would be something like heavy lunch. Okay, it would be very, very light lunch we carry, essentially some dry food most of the time, and some fruits maybe. Okay, what we carry is some snacks, some cakes, and some fruits sometimes, and of course water is absolutely required. Okay, so that is also part of the field work to get to know these things. Do not think that these logistics, the logistic part is not an academic part or unimportant. When it comes to field work, each and everything what Professor Mukherjee said from the beginning, including the list, are important. Okay, so everything is very, very important. This why full sleeve thing. He explained that when you climb up these hills, there are so many bushes and all, and you will be hurting yourself. Okay, if you do not wear the proper dress for the field work. Okay, so all these things are important. Anyway, so when we look at this particular spot, you can see that there are several. If I just can I? Yeah, I think I can enlarge it. Yeah, if I enlarge this picture, you see that there are one prominent structure which is very, very apparent from this picture. If I just zoom in, that there are several layers. Layers. I'm saying layers. I'm using the term layer. It is not a correct term here in this case, but just I'm showing. You do not see layers in case of in igneous rock. Layers are, the term layer is used for sedimentary rock, right? Why? Because sedimentary rocks are formed layer by layer. Okay, by the deposition of sediments layer by layer. Okay. Anyway, it is an igneous rock and plutonic rock, and you see this kind of layer-like thing. Okay, here, and if you look at this particular place here, also you can see. Okay. And here you can see like this. So what are they essentially? Can anyone say what are these structures? What are these structures within this granite? I mean, it is very prominent, and it is not that in a small portion we are observing. Throughout the area you are observing. See, and they are oriented at a particular inclination. You see, if you look at these, it is almost similar here also, right? So there's something definitely some characteristics of this particular rock mass. So what are they? You can see such fractures here also, okay, but they are not inclined or they are not oriented in the same fashion as these planes are. Okay, what are they? They are essentially joint planes. Okay, they are essentially joint planes. So how these joint planes are formed? When you see these kind of joint planes in granite, how do they form? See, if I just show you a quick this thing, a diagram. Let's say this is the Pluton, right? Let's say, sorry. So let's say this is the Pluton, right? And it is subsurface at a great depth. Okay, so this magma would be cooling down very slowly because it is at a depth. Okay, and when it cools down, and this is the shape of the body, let's say. Okay, and when it cools down, what will happen? I mean, there will be tensile stresses that will be generated. Okay, there will be tensile stresses that will be generated. Why? Because they are getting cooled down. So when these these tensile stresses would be generated orthogonal to the isothermal surfaces, right? These tensile stresses would be generated orthogonal or perpendicular to the isothermal surfaces. Okay, and because of these tensile stresses, and depending on the geometry of this Pluton and also the rheology of the magma, this kind of joints would be formed. So they are actually cooling joints. Okay, they are the cooling joints. Now, why do we see different sets of joints? Okay, that means some joints are oriented in the same direction. Some other joints are oriented in some different direction. So all these things actually depend on the geometry of the Pluton, rheology of the magma, and